Hello, my name is Peter Moreno, and I will be presenting on Object Oriented Programming, or OOP, in Python. So the first thing we are going to explain is what is OOP, or Object Oriented Programming. Object Oriented Programming is a programming method that organizes code around objects that which represent, of course, real life and world entities, or just what we are coding at the moment, such as if sorry, each each um each object has its own data or behavior in Python terms. In Python terms, it's going to be more of like what's each one is going to have its own set of data, and also more so its functions on what you are going to be using. Why we use this is just going to make our lives more easier, such as its readability, reusability, and just makes everything just easier on us. That's why, like, you might just be using object oriented programming more because of what concepts it has inside. So, the first concept we are going to discuss is going to be a class concept. The class concept is going to is going to basically be the blueprint for our objects, such as excuse me, such as how you see right here. The class is named dog, and in it is going to have the self.name and the self and and the name. The self is going to be what the object is called, and of course the name is going to be the name. An example is going to be, of course, here dog 1. Dog 1 is being assigned to dog Buddy. What is the self? Dog. What is the name? Buddy. And then, as you can see, print is going to show it's going to show Buddy, because that's what we have for dog 1. The next concept we're going to talk about is inheritance. Inheritance is basically going to allow us to create subclasses, or gonna let us reuse is gonna let us reuse what code we have in the main class. For example, we might have a class called animal, as you can see there, with a subclass called dog animal. We basically pass it, and we have all the code that is in animal. So how this is gonna work is it's going to print. It's going to have all the functionalities of animal, but you can add more or change things around, of course, to fit on what the dog subclass is going to be. This reduces more on redundant code, such as if you are going to use dog again and again and again and again. Sorry, animal code. Sorry, it's going. Sorry, it's going to make it more easier on us, because we're not going to be saying, oh, you're gonna this dog subclass is going to say bark, but we can basically just use class animal to say, hey, we have a dog here, let's make it bark. We can use the dog class. Here basically what I was gonna say here. D is assigned to dog. D speak. We change it up and it's going to say work. Polymorphism. So, polymorphism is literally means many forms. It allows objects from another class from different classes to respond to the same method in different ways. For example, here you can see both dog and cat classes have the speak method, but dog has print wolf, while cat says meow. You can loop through the list of animals, such as you see there. It iterates through the animal list, and calls for speech on each one, and they will respond to their respective speak methods. This makes it more. This makes the code more flexible onto what it is working with, such as like right here, of course, animal dot speak. You don't have to like say dog dot speak, cat dot speak. You can just simply say animal dot speak since it's in the list. Oops, there you go. Encapsulation. Encapsulation is about hiding the internal details inside of a class, such as it's basically just creating private attributes inside of the class, such as you can see here, class account. The way we are going to assign a private class is going to be underscore underscore. So the private class for here is going to be underscore underscore init underscore underscore. And why we do this is to protect the inner state of an object so that it doesn't get misused by outside code. Finally, we got abstraction. Abstraction just basically means hiding implementation details, showing only the interface. So it lets you focus on what the object does and not how it does it. In Python, you can use the abstract base classes to define a common interface and let the concrete classes implement the details. For example, you might define an abstract shape class, as you can see right there, with a method called area. You don't really care on how the shape calculates its area. Each subclass, like right here, like for example, I guess circle or rectangle, it implements it via their own way. Alright, so to wrap up, we're going to quickly explain what each object oriented program does. So classes are basically the blueprints. Objects are basically instances inside the classes. Inheritance, we can reuse the code that is given to us by other classes. Polymorphism, same interface, different behavior. Encapsulation, data protection, of course, private attributes, and abstraction hides the complexity, gives you the data. Thank you, and I hope this was quite understandable. I'm so sorry. My explanations probably sometimes aren't the best, but I hope it was more understandable on what I was trying to explain. Thank you.